We have already learned three groups, homologous series: alkane, alkene, alkyne. Now we go ahead and learn a new one, and that is alcohol. All alcohols end with OL. The functional group is OH. So the general formula of an alcohol is R, and OH is its functional group. Look at the first alcohol, which has got one carbon. So here is the carbon. Now every carbon has got 4 arms, 1, 2, 3, 4. To this one arm is attached OH, hence it becomes alcohol, and then we have H, H, and H. So the molecular formula in this case is CH3OH. The functional group is OH, and because it has got one carbon, it is called methanol. So it's methanol. OL means alcohol, it has an OH group, and meth means it has got one carbon. Now let's go to the alcohol with 2 carbons. The second member has got 2 carbons, so which means you'll have one carbon here and another carbon. Each carbon has got 4 arms, 1, 2, 3, 4, and to that we attach the hydrogen. So hydrogen, hydrogen, hydrogen. The 4th arm is attached to carbon. Now we go to the next carbon. So here is the next carbon. It has got 4 arms, 1, 2, 3, 4. The 4th one is attached to OH. That's why it becomes an alcohol. So this is an alcohol with 2 carbons, and the formula, if you see, the first has got 3 carbons attached, the second carbon has got 2 hydrogen attached, and the functional group is OH. 2 carbons means it is ethane. So it is ethanol. OH, that's why it is all, and ethane because it has got 2 carbon. Now for the 3 carbon. Third member has got 3 carbons, so we have 3 carbons here, 1, 2, 3 carbons, and remember each one will have a hydrogen. So 1, 2, 3, 4 arms, hydrogen, hydrogen, hydrogen. Now we go to the next carbon. It has got 4 arms, 1, 2, 3, 4. So that again you will have attached to hydrogen. So there will be a hydrogen here, hydrogen, and then we have the third one, which will have also 4 arms, 1, 2, 3, 4, and you will have hydrogen, hydrogen. So and the OH, which makes it an alcohol. So the formula of this will be first carbon with 3 hydrogen, second carbon with 2 hydrogens, and third carbon with 2 hydrogens with OH attached. Now it is all because it is alcohol, there is an OH to it, and 3 carbons. So 3 carbons means propane. So propanol. Propane is 3 carbon. Propanol is 3 carbon alcohol. Next we go to the 4th member. 4th member has 4 carbons. So we write 4 carbons, 1, 2, 3, 4. Now it is an alcohol, so you got to attach an OH. Now each carbon will have 4 hydrogens. So I have 1, 2, 3, and this is the 4th one. So I put hydrogen, hydrogen, hydrogen. Now the next carbon will have 4 arms, 1, 2, 3, 4. So I put hydrogen, hydrogen. The next carbon here will have again 4 arms, 1, 2, 3, 4. So we put hydrogen and hydrogen. And now we have the last carbon, which will also have 4 arms. So 1, 2, 3, 4. H, H. So the formula for this will be the first carbon will have 3, the second carbon 2, then the next one also 2, and the next one also 2. Each one of them will have 2, and the OH attached to the last. Now it has got 4 carbons and hence it is butane. Butane. And you remove the E and you put the OL, butanol. OL means OH, 4 carbon alcohol. Then we go to the 5th member, which is 5 carbon. So we have 1, 2, 3, 4, 5 carbon. It's an alcohol, so we got to attach OH. And now we put the 4 arms. First carbon, 1, 2, 3, 4. So hydrogen, hydrogen, hydrogen. Second carbon, 4 arms, 1, 2, 3, 4. So hydrogen, hydrogen. Then we have the next carbon, 4 arms, 1, 2, 3, 4. Hydrogen, hydrogen. Then we go to the next carbon, 4 arms, 1, 2, 3, 4. Hydrogen, hydrogen. 5th carbon, 4 arms, 1, 2, 3, 4. Hydrogen, hydrogen. Now for the formula, it's a long formula because 5 carbons. The first carbon attached to 3, second carbon to 2, then to 2, then next to 1, 2, 3, 4, then we have 5. And the last one is attached to OH, which makes it an alcohol. The functional group of alcohol is OH. So this is 5 carbons, so it will be pentane. Pentane. Now the E, you take away the E and you put OL, so becomes pentanol, 5 carbon alcohol. Just to revise it, the 1 carbon alcohol will be CH3, 1 carbon with the OH, and we'll call that methanol, 1 carbon alcohol. Then when you have 2 carbon alcohol with 2 carbons, so that would be CH3, CH2, and here you have OH. 2 carbons means ethane, so you write ethane. You rub the E out and you put OL, ethanol. Then we have the 3 carbon alcohol, 3 carbon alcohol, CH3, CH2, CH2, and then the OH to make it alcohol. 3 carbon means propane, and because this is alcohol, you take away the E and you put OL, so propanol, 3 carbon alcohol. Then we go to 4 carbon alcohol. The 4 carbon alcohol will have 4 carbons, so CH3, 1 carbon, 2 carbon, 3 carbon, 4 carbon, and it's an alcohol, so it is OH. Now the name 4 carbon means butane. Butane. Now the E we take away and we put OL, so you get butanol. So that is a 4 carbon alcohol. Now for a 5 carbon alcohol, you'll have 5 carbons. CH3, 1 carbon, 2, 3, 4, 5. It's an alcohol, so it is OH. Now 5 carbon, so pentane is 5 carbon. You have to remember that, pentane. And because it's an alcohol, you take away the E and you put OL, pentanol, 4 carbon alcohol. We'll learn the next group. The next group is carboxylic acids. And the functional group for carboxylic acids is COOH. General formula RCOH. So the first member having 1 carbon, here is a carboxylic acid, COOH, and the carbon is already taken up, so we have only 1 hydrogen attached here. So this is the first member. Now all acids have got the ending of OIC. Now this is one carbon, so it will be methanoic acid. One carbon acid. Then we go to second member, two carbon acids. So we have the here OOH. This is a functional group of the acid. There's one carbon already there, so you can put one more carbon. Now this carbon will have 4 arms. So the formula of this will be CH3, that is, and COOH, that is a functional group. Now it's an acid, so it ends out with OIC. It's got 2 carbons and hence ethanoic acid. You remove the E, you put the oic, so ethanoic acid. For the third member, it's got 3 carbons. Now here I have shown you the structure of the carboxylic acid. There's a carbon attached to H, and this is the structure. See, remember it is COOH. There are two oxygens and 1 hydrogen. So this is the structure. And we need 3 carbons. 1 carbon is already there, so we'll put 1 more carbon, 1 more. Now 3 carbons. So the first carbon, 1, 2, 3, 4. For second carbon, 1, 2, 3, 4. And we put the hydrogens. So we'll get now the formula will be first carbon has got 3 hydrogens, second H2, and then we have COOH. So it is got 3 carbons. 3 carbons means propane. And it's an acid. So we remove the E and put the acid, or acids are OIC, so propanoic acid. And for fourth member, 4 carbons. Here is a functional group. And we need to attach 4 carbons. 1 carbon is already there, so we'll 1, 3, and this is 4. Each carbon should have 4 arms. So this is now 1, 2, 3, 4. So we'll have hydrogen, hydrogen, hydrogen. The next carbon also will have to have 4 arms. 1, 2, 3, 4. So that would be now hydrogen, hydrogen. And next carbon also 4 arms. 1, 2, 3, 4. So we have hydrogen and hydrogen. So if you want to write the formula, it will be CH3, CH2, the third carbon CH2. So we have 3 carbons, and then we have the functional group. COOH is a functional group. That is why it is an acid, oic. Now it is a 4 carbon. 4 carbon means butane. So it will be butanoic acid. You remove the E and you put OIC, butanoic acid. So if I want a 1 carbon acid, I first need to put my functional group COOH, and the OH is, or the carbon is already there, so this will be my first acid, and I will call it methane because it is 1 carbon, and I remove the E and make OIC, methanoic acid. 2 carbon acid. By now you would have guessed 2 carbon acid. 2 carbon means ethane, ethanoic acid. And if you were to write it, it will be now COOH because it is an acid. It has to have 1 more carbon, so CH3COOH, ethanoic acid. With 3 carbon acid is propane, so that would be propane. You remove the E and you put OIC, propanoic acid. It's an acid, so you put COOH. We need 3 carbons. 1 carbon is already there, so you have 1 more carbon here, will be CH2. It's in the middle, so it is CH2. This carbon is in the end, so it will have CH3. So this is propanoic acid. The fourth member will be with 4 carbons. 4 carbon acid. 4 is butane, so butane. You remove the E and you do OIC, butanoic acid. So we have COOH, which is the functional group of an acid. Now we need to have 4 carbons. So 1 carbon is already there, CH2. The middle carbons have only 2 hydrogens. It is the last carbon that has got 3 hydrogens. So this would be butanoic acid. Now for the fifth one, say fifth with 5 carbon acid will be pentane. You remove the E and put acid, OIC, pentanoic acid, and here it will have COOH because it is an acid. It has to have 5 carbons. 1 carbon is already there, so we have 1, 2, 3, 4, 5 carbon. The middle carbons always have 2 hydrogens. It's the last carbon that has got 3 hydrogens. So this is pentanoic acid. Now for the next group, that is aldehyde. Now for the aldehyde, the functional group is CHO. And the CHO is carbon, 1 hydrogen, double bond, oxygen. The general formula for an aldehyde is R, and the functional group CHO. So the aldehyde carries the name Al, like methanol, ethanol, propanol, from the word aldehyde. Let's start with the first member of the aldehyde, which is 1 carbon. So here is 1 carbon, and this is the functional group, C double bond OH. This is the functional group of the aldehyde, CHO. Now if you see, only 1 more carbon can be attached because a carbon has got 4 branches, 1, 2, 3, 4. So this is the first member, and it is HCHO. It is Al because it is aldehyde, so the name is methane. Methane. You remove the E and you put a Al, so that becomes a methanol, a 1 carbon aldehyde. Then let's go to a second member. It's got 2 carbons. So the functional group is here CHO. There's 1 carbon. The 1 more carbon can be attached. So here we put 1 more carbon. The carbon has got 4 arms. So it is H, H and H. So the formula will be CH3 and the functional group CHO. It is a 2 carbon aldehyde. So you write ethane. You remove the E and put Al, ethanol. Now for third member of the aldehyde, 3 carbons. So first the functional group CHO, and then we need 3 carbons. So there's 1 already in the functional group, 2, 3 carbons. Each carbon has got 4 arms. So there is hydrogen, hydrogen, hydrogen. The next carbon here will have also 4 arms. So 1, 2, 3, 4. The formula for this, 3 carbons. So first carbon with CH3, the second carbon CH2, and the third carbon is a functional CHO. 3 carbons, so propane. You remove the E, and because it is an aldehyde, CHO group, propanol, Al. We go to the fourth member with 4 carbons. So we attach 1, 2, 3, 4 carbons. The last carbon will have the functional group, CHO. And then each carbon's got 4 arms, 1, 2, 3, 4. Then we go to the next carbon. We'll have 4 arms, 1, 2, 3, 4. Then we go to the next, the third carbon, 1, 2, 3, 4. And the fourth carbon, have you seen, it's got 4 arms already. So the formula for this is CH3 for the first, CH2, CH2 second, the third, and the fourth one CHO. 4 carbons means butane. So this will be B-U-T-A-N-E, butane. You remove the E to make it, put Al, butanal, a 4 carbon aldehyde. So to go over the aldehyde, we'll just summarize all the aldehydes. The 1 carbon aldehyde will have just 1 carbon. So you have CHO, which is a functional group, and there will be H attached. So that would be methane. Because it's an aldehyde, remove the E and you put Al, methanal. A 2 carbon aldehyde, because it is an aldehyde, it will be CHO, and it has to have 2 carbons. 1 carbon is already in the functional group, CH3. It's 2 carbons, so it is ethane, and you rub this out, make it an aldehyde, ethanal. We have 3 carbon aldehyde. 3 carbon aldehyde, 3 carbon is propane. You remove the E, you make Al, propanal. Now to write propanal, first you know it's an aldehyde, so it's CHO. It has to have 3 carbon because it's propane, so 3 carbon. You need to put 3 carbon. 1 carbon is already there, so 1, 2, 3. The last carbon will have 3 hydrogens. The middle carbon will have 2 hydrogens, so this will be propanal. Now for 4 carbon, now 4 carbon is butane, and because this is an aldehyde, you take away the E, butanal. So to write the formula, first CHO, because it is aldehyde. Now you need to put 4 carbons. 1 is already there, 2, 3, 4. The terminal carbon will have 3 hydrogens. This will have CH2 and this will be CH2. So butanal, 4 carbon aldehyde. Now if you want to write a 5 carbon aldehyde, 5 means pentane. And to make it an aldehyde, remove the E and you put Al, pentanal. So that is CHO. Now you have to give it 5 carbons. 1 is already there, 2, 3, 4, 5. The terminal carbon will have 3 hydrogens, then all will have 2. The middle ones will have 2. This is pentanal. For the next group, it's called the ketone. And in the ketone, the functional group is C double bond oxygen. So we can put like this. Remember, carbon has to have 4 arms. So 1, 2, 3, 4 arms. So unlike the other groups, ketone has got 2 available. So 2 arms available. So you have carbon here with double bond, that is a ketonic, and you have both these arms available free. So on either of these arms, on either sides, we have the carbon that gets attached to it. And all the ketones end with O-N-E. Now the first member of ketone will have 3 carbons. And why will it have 3 carbons? All others first member had 1. Most of them have first member had 1 carbon, but first member will have 3 carbons. Because if you notice here, this is C, this is the functional group. And the functional group has got these 2 still available. And 2 carbons will attach, one on this side and one on this side. So the first carbon, 1, 2, 3, 4. And this third carbon, 1, 2, 3, 4. So you put hydrogen, hydrogen. So this will be CH3 because it is terminal, then you have CO functional group, and again CH3. Now this is a 3 carbon. 3 carbon means you write propane, and the E you will take away and put O-N-E, propanone. Now when we have 4 carbon, second member will have 4 carbon. So first we write the functional group, that is C double bond O. Now we got to attach 4 carbons. So you have 1, 2, 3, and the 4th from the functional. Look at the first one, 1, 2, 3, 4. Second one, 1, 2, 3, 4. And then you have the last one, carbon 1, 2, 3, 4. You attach hydrogens. And it will go this way, CH3 terminal 1, then the functional group CO, then you have CH2, CH3. 4 carbons means it will be butane, and because it is an ketone, butanone, O-N-E, ketone, butanone. Now for third member will have 5 carbons. So you have here the functional group. The functional group could be in the first place, second place, or third place. Here everywhere I am putting the functional group after the first carbon, but need not be always after the first carbon. It could, now you have 1, 2, 3, 4, 5. Now each carbon has got 4 arms, 1, 2, 3, 4, where you attach your hydrogen. Then you see this carbon, the second carbon has got no more place. 1, 2, 3, 4. There's no hydrogen, cannot attach to it. Now we'll go to the next carbon. Here 4 arms, 1, 2, 3, 4. Right? 1, 2, 3, and 4. So we have hydrogen, hydrogen. Next carbon. 1, 2, 3, 4. So here it will have hydrogen, hydrogen. And the last carbon, 1, 2, 3, and the 4th one attached to the carbon. And here again you have hydrogen, hydrogen, hydrogen. So it will be, the first carbon is CH3, then the functional group CO, and then we have CH2, CH2, and CH3. Remember, we need 5 carbons altogether. And because it's 5 carbons, we have pentane. And this pentane, we take away the E and we put O-N-E, that is pentanone. Now this pentanone could also be written in this manner, CH3. We could do it CH2 and put the carbon also functional group in this. It's got a different name. For now we will just call it pentanone. This is 2 pentanone, this is 3 pentanone. For now we'll just call it pentanone. We've got 5 carbons with a CO. Now for the 4th member, we'll have 6 carbons. So you have 1, then 1 carbon, then you have the CO, of course, which makes it a pentanone, which makes it a ketone. Then we have 1 carbon, 2, 3, 4, 5, 6. And I'll straight away write CH3. This will be CH2, 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 and here CH3. Now 6 carbon means hexane. And hexane, you take away the E and you put O-N-E because it is a ketone, hexanone. Now when it comes to ketone, first we must know the functional group is C double bond O with 2 more still available. So the attachment takes place on either sides. So we cannot start with 1 ketone, 1 carbon There is no 1 carbon ketone, there is no 2 carbon ketone. We start straight away from 3 carbon ketone. So we have 3 carbon ketone, this is the ketonic group, and we attach the carbons. So CH3 on the side, CH3 on the side. It's 3 carbon, so propane. You take away the E and you put O and E, propanone. Then you have 4 carbon ketone. So here again you first put the functional group and you put 1 carbon on the side, so you got 2, and 2 carbons on this side. So 4 means butane, and you take away the E and then you put O and E, butanone. So when you have a 5 carbon ketone, here is your ketonic group. Now you need to put 5 carbons. So I put 1 carbon here, 2, now it is 3, 4, the last has got CH3. So this is pentane, and you take away the E and you put O and E, that becomes pentanone. Now for 6 carbon. So 6 carbon, first you put your functional group and now attach your carbon. So CH3, 1 carbon, 2 carbon, this is 3 carbon, 4, 5, the last carbon is CH3. So that would be hexane, would be your aldehyde, your alkane, and then you take away the E and you put ONE, that becomes hexanone, 6 carbon ketone. Propanone, this is a 2 carbon ketone. Butanone, 3 carbon ketone. Pentanone would be a, butanone is 4 carbon. No, this is wrong what I have done. Propanone is a 3 carbon ketone. Then we have butanone. Butanone means 4 carbon ketone. Then we have here 5 carbon ketone, and last we have 6 carbon ketone.